problem. He's a pretty big problem. Lauren, what's his problem? Very good. His name is Brian, and he had a plane crash. And obviously he's going to need some food, right? He's sick of eating tree bark. So he attempts to do what? He attempts to do what? What is his goal? Andrew? He tries to catch fish, right? And I'm not going to reread all of it, but I'm going to reread where he kind of left off. Remember, he is trying to use what kind of tool? What kind of tool? RJ? A bow and arrow. He would pull the bow back, set the arrow just above the water, and when the fish was no more than an inch away, he would release. Only he would miss. It seemed to him that the arrow had gone right through the fish, again and again, but the fish didn't get hurt. Finally, after hours, he stuck the arrow down in the water, pulled the bow, and waited for the fish to come close. And while he was waiting, he noticed, and that's where we left off. And then we did some activities, and I guess I should pull those up so you guys don't hear about box stuff too. We did some activities, some stations, while I was gone. One of them kind of looks like the pencil in the water. It's very similar to when he put the bow in the water. What do you think Brian noticed about the arrow when he put it in the water? If we want to go back and kind of remind yourself, what did he see? What did he see? If the arrow looked anything like the pencil, the arrow looked what? Heidi? Broken. Broken. Looked broken. Of course, he had forgotten that water refracts. It bends the light. He had learned that somewhere in some class. Maybe it was biology. He couldn't remember. But it did bend the light, and that meant that the fish were not where they appeared to be. They were just lower, just below, which means he had to aim under them. Okay? So it wasn't biology, because biology is the study of life. But it was science class. It was physics, and that's kind of what we're studying now. That the material, what's the synonym we use for the word material? What's the synonym for the word material? Lucy?
Medium.
Medium changed, didn't it? Now let's kind of revisit. I know it's kind of been a week, but we started with this activity. Our question was, how did the light cross the box to get to the other side? And the first time we did it, we laid this flashlight down, right, on the paper. And we know that light travels in a straight line. Okay? And did it do what we expected it to do?
No.
Yes, it did, right? Remember, there isn't any, what's the medium on the first trial that we did? It was just this laid down on the paper. What was the medium, Ellie?
Air.
Air. Okay, some of you are like, well, there's nothing there. Yes, there is. There's air. And it did travel in a straight line. What happened, though, when we did change the medium? We laid down what is, you guys thought it was glass, and that's okay. You guys laid down that acrylic block. What happened to the line as it left? What happened to it? So it went in, and then when you connected the dots, what did the light look like? What did the light look like? What did it look like? Tanya?
It looked like it was bent.
It did look like it was bent, didn't it? It did look like it was bent. I'm trying to recreate that a little bit here. Someone undid my line. Okay. Now, what changed right here? What changed what the light was in right here? At this point, it creates an angle. What changed? Sarah? The medium. The light went from going in air to to the what? To the block, right? And when we have over here, we have, now it comes from the air, or not from the air to the block, but the block to the air. And it creates an angle. It's not straight anymore, right? It shifts or moves. Okay? Let's forget about this for a second. Let's imagine that I'm going to represent the light, but I'm going to pretend that I'm light, but I'm running through the beach. I'm on the beach. I'm just running. My body is the ray of light. I'm running. What is the medium that my body is running through right now? What's the medium? What's the medium, Talia? The air. And I can run pretty quick, right? Am I going to be able to keep moving as fast if I change the medium and then run into the ocean? No. I'm probably going to go like that. And that's exactly what light does. Because these things, air and the glass, have different densities. Which is more dense, a rock or a cotton ball? You guys should kind of know about density. A rock or a cotton ball? It's more dense. A rock, right? The molecules are more close together. Okay, just like solids are more dense than gases. And so when the light goes from less dense to more dense, it's just like me running on the beach. I'm in a gas, I'm running in a gas, and then I run into a liquid, I go, Arr! Well, let's say I finally run out of the water, back into the air. Do you think I can speed up again?
Yeah.
I can, and that would cause me to shift over. Well, remember, all you see, guys, is the light coming to your eyes. Everything you see is just a ray of light coming to your eyes. And normally we said it's always a reflection. Well, or it's light refracting after it reflects. Okay. So let's see how that affected Brian. Let me give you another example. Now, this isn't exactly a fish. I don't know, let's pretend it's a fish. I don't know. Let's say that this is a snake or something. Okay, and here's the water, and here's your eye. Okay, so when the light goes in, and it's gonna, right here, it goes from water to what, everyone? Air. And those are different mediums. So what that's going to do is that is going to make those angles. And your eye, it's kind of tricky because your eyes see it, that it's right here. So if this were this fish and Brian were trying to spear it, he keeps hitting this right here because that's what the light tells him. Because the light has shifted up. Because we, in our eyes, our brain thinks it's a straight line. But if he keeps hitting this, is he ever going to hit the fish?
No.
No. He actually needs to aim just a little bit below it. Right? Refract. Where did my marker go? Oh, good. Thanks. Diamonds are another thing. Ladies love them, don't they? I guess guys can love them too.
No.
No, you don't love them? You don't want any bling? Huh?
Just for money.
You just want to have it for money? Oh, okay. We have to have some money to have. Anyway, that's why diamonds sparkle so much. One of the ways is that they're cut, but diamonds are the hardest rock. Or, it's not really rock, it's really a mineral. And it's because of the light refracting. Okay? So that is refraction. Now, we're going to move on to something else that many, many of you have on your face right now. Many of you depend on light refracting in order to correct your vision. Okay, so we're going to move on to that next. But Ellie's going to stop